I'm Tad Allen. Welcome to CHOP. Today's challenge is to create an unforgettable 3D polymer. Let's meet our competitors. And first up, Enrique Flores.
Ever since I was 5, I knew I wanted to do 3D printing. And today, I'm here to show that I'm the best at what I do.
And next up, we have Stephanie Smith.
Hi, my name is Stephanie Smith, and I'm a PhD candidate at UC San Diego, and I am doing cutting-edge research in polymers and their applications in 3D printing.
As you know, today's theme is 3D polymerization. The figure to be made is the Eiffel Tower. Starting now, Alice Jimmy. Hey Enrique, how are you approaching today's challenge?
Hey Ted, how you doing? As far as today, I totally went for the PLA filament, which is a thermoplastic. So now all I have to do is put the base inside the printer, and what essentially is going to happen is the thermoplastic is going to be heated, and it's going to go through a nozzle, and it's going to be put layer by layer inside the base in order for me to create my Eiffel Tower model.
Hey Stephanie, how are you going to approach today's challenge?
Hey, I'm going to approach today's challenge by using CLIP, or Continuous Liquid Interface Production Technology, and that's really the latest and greatest there is in polymerization 3D printing technology right now. And the thing that's really cool about CLIP is that it harnesses the power of light for the polymerization reaction, but also oxygen as an inhibitor for this photopolymerization process. And how it does that is it takes a special Teflon-based transparent and oxygen-permeable window, which allows both light and oxygen to get through. You can kind of think of it like a big contact lens. And the machine that I'm going to be using, my trusty UV oven over here, that is going to be able to control the exact amount of oxygen and when that oxygen is permitted to enter into my photosensitive resin. And this is going to be, it's going to give me a really precise result, and it's going to be fast. That's really important here because we have such a limited time frame, and I think it's going to be good. I am just about done coating my model that I'm going to program into the UV oven, and I'm just, yes, here we go. Here's my 3D model for the Eiffel Tower, and I'm going to program that into the UV oven and mix up my photopolymer resin, and we're good to go.
15 minutes remaining, contestants.
Alright, just putting my reaction mixture in and UV light. Now we wait.
Hey judges, what do you guys think of the competition so far?
Hey Ted. Well, I feel like Enrique definitely chose a safe route as far as the competition goes. He decided to choose the FDM processing, which is widely used in the industry because it's extremely cheap. For about 1 kilogram of filament, it essentially costs about $25. And there's a variety of blends of filaments out there. You can get it in wood, metal, carbon, or a mixture of those materials. But as far as Stephanie goes, she's using a fairly new technique that I'm not too sure about how it works. Can you fill me in on that, Anna?
Yeah, actually, Louis, I have been studying the CLIP technique, or continuous liquid interface production technique, recently, because it really is the latest and greatest in this kind of polymer-based 3D printing technology. And like Stephanie mentioned earlier, the key here is the oxygen introduction in that Teflon transparent layer. And the oxygen acts to inhibit the resin from curing in certain areas, and the light cures the areas that do not have the oxygen there. Now, the oxygen containing layer of the resin is called the dead zone, as polymerization is impossible there because the oxygen does not allow the free radicals that the photo initiator produces to actually reach the monomers and the oligomers to induce polymerization. And in this machine that she's going to be using, her UV oven, it's going to produce a series of cross-sectional images of her design that she programs in of the Eiffel Tower, and it's kind of like a projector. So instead of layer by layer or kind of point by point, as you might imagine a laser synthesis procedure to be, it's much quicker.
10 seconds remaining, contestants. 5, 4, 3, 2, 1. Time's up. Hands up, contestants. So, judges, do you guys need more time on your decision?
No, I think we're ready to talk to the contestants.
Yes, so Stephanie, by using clip and bringing oxygen into the equation, you really took the traditional mechanical technique for 3D printing, and it suddenly became this tunable photochemical process, and it rapidly decreased your production times, it removed the layering effect, and it really provided a technology that just may take 3D printing to the next level. Congratulations on your successful use of the continuous liquid interface production technique.
Enrique, you chose the FDM process, which is great for creating cheap models and for creating a lot of models, actually. That's why industry uses it. But unfortunately, it takes a lot of time. You actually need about 16 hours to do your model. So for that, Enrique, you've been chopped. Congratulations.